Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem K largest elements. Okay, so what the problem saying is we'll be given an array of positive integers and an integer K. Our task is to return K largest elements in decreasing order. Okay, so here is a given array and here is a given K. Okay, now what we want to do is which are the K largest elements in this particular array? Those are 50, 30 and 23. Okay, so these are the three largest elements in the given array and we have to return them and we have to sort them in decreasing order and return them. Okay, so I hope you have got the problem. Now let's see how we can solve this problem. Okay, so now first let's come to the expected approach. Okay, let's come directly to the expected approach, how we are going to solve this problem. So we are going to use the property of minimum heap. Okay, so what is a minimum heap? Minimum heap is a data structure. It's a tree, okay, which stores the minimum element at the top. Okay, the minimum element at the top. So let's see. Let's dry run this approach. Okay, how we are going to solve this problem. So for example, here, right? So first of all, we are going to ingest the k number of elements in the minimum heap. So this is our minimum heap, let's say. So what are the k elements? So the k elements will look like this. So it keeps the sorted. So for example, these are the first k elements, k equal to 3. So these are the elements we have ingested in our minimum heap. Okay, so this is our minimum heap. Now what we are going to do, we're going to start. So at each time, we'll be having k number of elements only. The size of this minimum heap, it is going to be k only. Okay, so now we're going to go to this particular element, right? We're going to start iterating the remaining elements, right? So we'll start with this particular element at 9. Okay, and what we're going to do, we are going to check, is this particular element 9, is it greater than the minimum element in this minimum heap? And what is that minimum element? It will always be stored at the top. We can consider this as the top, right? So yes, this 9 is greater than 1. So we are going to remove this 1. We are going to remove this 1 and we are going to ingest this particular 9. So this looks like this: 9, 12, 23. Okay. Okay. Now we're going to go to the next element, 30. We are again going to check, is 30 greater than the top element of minimum heap? Okay. Is it 9? Yes, it is 9. So it is greater. 30 is greater than 9. So we are going to remove this element and we are going to ingest 30. So after ingesting 30, it is going to look like this. So the minimum element is going to come at the top, which is 12, then 23, and then 30. Okay. Then what we are going to do? We're going to check this next element, which is 2, right? Which is 2. We're going to check, is 2 greater than 12? Is 2 greater than 12? Which is 12 is a minimum element in the minimum heap. No, it is not. It is not greater. 2 is not greater than 12. Okay. So we are going to go next. We won't do anything. In this case, we're going to go to the next element. Now, is 50 greater than the top element 12? Yes, it is. Yes, it is. Then what we are going to do? We are going to remove this element and we are going to ingest 50. Okay. Now, after ingesting 50, it is going to look like this. It will always be sorted, and here is our final minimum heap state. Okay. Okay. Now, this is what we want to return. These are the elements we are going to pluck them out of this minimum heap. We are going to push in array or array list or vector. We are going to sort in the descending order and we are going to return. So what it will look like? So 50, 30 and 23. So this is how we are going to return our list of elements. Okay. Okay. So I hope you've got the intuition. Now let's go and code. Okay. Before going to the code, I just request you please subscribe to the channel, like the video. Okay. Thank you so much. So we'll also discuss the naive approach post this. Ideally, I should have discussed the naive approach first. That is a less optimized approach. Okay. So let's start. So first I'll show the Java code followed by C++. Okay. So I'll create the minimum heap. We create minimum heap using priority queue. It will be type of integer. Let's call it minimum heap. Okay. And then new priority queue and of size k. We are mentioning here of size k, we are creating our minimum heap. Okay. Now what are we going to do? Int I equal to 0, I less than k plus I. Okay. Min heap dot add of I. Okay. We have added the elements, the k elements in this minimum heap. Now post this. Now we have our, for example, if this was example, right? If this was array. So after this particular after this particular for loop, after this particular for loop, what is the state? What is in minimum heap? It is this 1, 12, and 23. Sorry, 23. So this is the first stage of the minimum heap. And these are the first three elements. Okay. And these are sorted in the minimum heap. Okay. Now, what we are going to do? We are going to now start iterating from k plus 1, right? Which is k. Basically, it is zero based indexing. Then I less than add dot length, then plus plus I. Okay. And now what we're going to check here, if add of I, if it is greater than minimum heap, if it is greater than top element, the top or minimum element inside the minimum heap, we check like this peak basically. If it is greater, then remove the element, remove the smallest element. Okay, remove the smallest element, ingest this element, minimum dot add of I. Doing this, at last, you in the minimum heap, you will have the k largest elements. Okay, the k largest elements. So yes, so that's what we have done here. So for example, if add of I was this, we are checking with this particular element, is 9 greater than add of I? Sorry, is 9 greater than this minimum heap dot peak? Yes, it is greater. Then remove this element, add 9 here, add 9 here. Okay, so this is it. This is now what we're going to do now. We are going to create an array list of integer result equal to new array list. Okay, while minimum heap is not empty, then result dot add minimum heap dot poll, right? Dot poll. And simply now what we're going to do, we are just going to reverse, or we are going to sort in collections dot sort, sorry, collections dot reverse. See, this adding from the minimum heap, right? It will give you in ascending order. It will give you sorted order, which we just want to reverse. This reverse will give you the sorting in descending order. That's it. Okay, result. And finally, we're going to return the result. Let's compile this. Let's submit it. Okay, thanks for watching. I hope you've got the solution. Now, what is the time complexity? We'll say the time complexity is O of n, because we are iterating through the array of n elements. Okay. Yeah, let's quickly see the let's quickly see the C++ code as well. So here's the C++ code. Thanks for watching. Please subscribe to the channel, like the video. Okay, so here is the C++ code. So so here's a priority queue, and then we are adding the first key elements in the priority queue. Then we are iterating through the rest of the array elements. We are checking is the array of I, if it is greater than pq.top, then we are popping that element out, and then we are pushing that particular array element. Okay, and here we have a result vector. Okay, we are ingesting the elements, right, from the minimum heap into the result, and then we are reversing, and then we are returning. That's it. So let us according to the description section. Thanks for watching. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.